Today we're going to start chapter 11, 11.1 and 2. We're going to do this in two sections. This is part A, basic graphs of sine, cosine, and tangent. We've been looking at sine, cosine, and tangent on the unit circle, and now we're going to look at it on the coordinate plane, where instead of the angle being around the unit circle, the angle is going to be along the x-axis. And y-axis is going to be the value of the function. Now, some vocabulary terms we have to know. Amplitude, that is the range of y values. This indicates how much energy is involved in the quantity being graphed. Higher amplitude means greater energy. So you can think of it as the height of the graph. Periodic, that's a term that means that the function is going to repeat itself. The cycle is the shortest repeating portion of the repeating function. So a sine and cosine graph repeats itself over and over again. Well, what is one section of it that we can represent as one cycle? The period is the length of each cycle. So it's going to be the distance, or maybe time, if that's what we're using for the x-axis, that it takes for the sine or cosine curve to begin repeating itself. Frequency, the reciprocal of the period, which gives the number of cycles per unit of time. So frequency is 1 over the period. Asymptotes, a line that the graph approaches as the value becomes undefined. Now, sine and cosine do not have asymptotes, but tangent does, because tangent can be defined in terms of sine and cosine like this. Tangent is sine divided by cosine. So when cosine equals 0, the denominator equals 0 and tangent is undefined, and we will have an asymptote at that point. We'll look at that a little bit later. So what do the basic sine and cosine graphs look like? Well, if we roll out the angles along the x-axis, okay, see it like this, the basic sine function, this is just y equals sine of x, is going to look like this. It's going to have a range from -1 to +1. The domain is going to be all real numbers. So we can have an infinite domain here. The period, the sine graph starts in the middle. And if we go to the maximum of 1, and then we come back down to 0, and then to a minimum of -1, and then back up to 0, that's where we start to repeat ourselves. So the period of this function is 2 pi. Now, you'll look, we have x-intercepts here at 0, at pi, at 2 pi, 3 pi, 4 pi, and so on and so forth, and then negatively, -pi, -2 pi, and so on. Now, for cosine, you'll notice that the graph starts when we're at cosine of 0 at a maximum of 1. It crosses the x-axis at x over 2, hits a minimum, pi over 2, hits a minimum at pi, comes back to 0 at pi over 2, and then it comes back to its maximum at 2 pi. So its cycle, its period, is 2 pi as well. And it crosses the x-axis at pi over 2, 3 pi over 2, 5 pi over 2, and so on and so forth. The y-intercept, it's going to cross the y-intercept, the y-axis in exactly one place. For sine, that happens at 0, 0. For cosine, it happens at 0, 1. All right, let's talk about amplitude and period. Now, on the previous slide, my function was just y equals sine of x and y equals cosine of x. But now we can multiply that by a in front, that's the amplitude. So amplitude and period are always positive numbers. So amplitude is going to be the absolute value of a. And if a is negative, Okay, the amplitude is still positive, but it means that our graph is going to be flipped across the x-axis. It's going to be a mirror image. Now, the amplitude, if you calculate it, is actually half of the total range. So the amplitude goes from, if we look at the previous slide, from 0 to 1 for a sine, so the amplitude is 1. We'll take a look at some examples of some other amplitudes. The period is a little bit trickier. It's defined as 2 pi divided by absolute value of b. So as b increases, the period decreases. As b decreases, the period increases. So how do we graph these things? We do it by these steps here. We want to label the x-axis to show amplitude, label the y-axis to show, y-axis to show amplitude, and x-axis according to the period. The min and max for the y-axis are going to be negative amplitude and positive amplitude. And then we have to find where the 3 intercepts are that are greater than 0. Now, how can we do that? Well, the quadrantal angles, okay, those that happen at pi over 2, at pi, at 3 pi over 2, and then at 2 pi. So from 0 to 2 pi, there are 5 key points on the graph. So it cuts the period into 4 equal pieces. So we can, when we label the x-axis, each tick mark, we can mark it as the period divided by 4. And we'll look at an example in a second here. All right. So here's just some examples of amplitude. So in the blue line here, amplitude is equal to 1. So that we would not have to write 1 times sine of x. It would just be sine of x. Now, as a increases, if you look at the red one here, this is some variation on a sine function. And as a increases, well, the height increases, the amplitude increases. Now here, the green one, as the amplitude decreases, the amplitude is much smaller. So here's some examples of period. Here, the f of x equals cosine x is in purple here. And we start at a height of 1. And here at pi over 2, we hit 0. And then at pi, we're at negative 1. And at 3 pi over 2, we're back to 0. And then at 2 pi, we're back to 1 again. So that would be the period of 2 pi. Now, if you look at the green one, g of x equals cosine of 4 times x, we have 4 times as many periods in one period of their normal function. So here I've got 1, sorry, here's 1, and then 2, and then 3, and then 4, all the way to 2 pi here. Okay. Now, the blue one, it's cosine of x, a cosine of 0.25x, so it's going to be 4 times as long, and it would take a much, much longer time to repeat that period. All right. So as b increases, the period decreases. So the green gets shorter, the blue gets longer. And amplitude here is, they're all an amplitude of 1. It's just the period is different. All right, let's take a look at an example here. So use the graphs of sine and cosine functions as a guide. Graph the function for 2 full periods. And we could do one negatively and one positively. We'll see how this looks. So if I've got y is equal to a times sine of bx, well, my amplitude is a, the absolute value of a, so that's going to be 4. My period is 2 pi divided by absolute value of b. Absolute value of b here is just 1. So the period is just 2 pi. So Let's take a look at my my graph here. I'm going to have a tick mark at each of my 2 pi divided by 4. So every pi over 2, I'm going to put a tick mark. So pi over 2, pi, 3 pi over 2, 2 pi, and then negatively as well. My amplitude goes up to 1, 2, 3, 4, and 1, 2, 3, negative 4. Now you'll notice here that my scale is not the same because 2 pi over here would be 6 and then 4 would be here. So it's not necessarily the exact same scale for the y and x-axis. If you practice these on your calculator, you're going to want to put your tick marks, like you can enter your tick marks as pi over 2, pi, 3 pi over 2 for your x scale on your calculator. And if you have questions about that, you can ask about that. All right, let's take a look at another example. So y is equal to cosine of 4x. So again, y is equal to a cosine of bx. My amplitude is absolute value of a. Well, that's just 1. Period is 2 pi divided by absolute value of 4. So my 2 pi is or my period is 2 pi divided by 4, which is pi over 2. So now my tick marks, okay, is going to be pi over 2 divided by 4, so pi over 8. So here I've got pi over 8, pi over 4, 3 pi over 8. This would be 4 pi over 8, and then negatively the same way. And my amplitude is 1, so now I have my 5 critical points here at 1, and then it comes down to 0 at when my x is pi over 8, pi over 4, I come down here, 3 pi over 8, pi over 2. So yeah, I would suggest, try practicing some of these on your calculator. Make sure you're in radian mode because we're dealing with radians here. And see if you can come up with some of these graphs. That will help you with checking your work. All right. Use a sine function to graph a sound wave with a period of 0.002 seconds and an amplitude of 3 centimeters. Find the frequency in hertz for this sound wave. So here is our basic form of the equation. My period is 2 pi um, divided by, my period is 2 pi divided by 0.2, okay, or my b is. So the period, the tick mark is going to be every 0.0005. So 0.005, 0.001, 0.0015, 0.0002. Okay. And then my amplitude is 3. And what is my frequency? 1 divided by the period. We said the period is 0.002. So the frequency is 1 divided by 0.002, which is equal to 500 hertz. So that would be the frequency. So this graph would go up and down 500 times in 1 second. All right, let's take a look at tangent graphs. Now, tangent graphs look quite a bit different than the sine and cosine graphs. They have a repeating pattern like this. Now, so some of the things we're going to have to think, domain is going to be all real numbers except for these asymptotes where cosine of theta is equal to 0 or cosine of x is equal to 0. So we're using x here. My range is actually all real numbers. Okay? Whereas for sine and cosine, it was defined by the amplitude. Now for tangent, it's going to be all real numbers for the range. Amplitude really is undefined, But the A is still useful to us because it tells us about where how the curve is going to look. And the A is going to happen halfway between where it crosses the x-axis and the asymptote. Halfway between there is where this curve starts to change directions. That's my A. So for this example, it's right at, here, right between 0 and pi over 2, so that'd be at pi over 4, right at 1 there. That would be my A. Sometimes you'll hear those called quarter points, okay? So you're going to have one here and here, okay? Remember, tangent is sine divided by cosine. And if I were to graph where cosine is 0 at pi over 2, 3 pi over 2, negative pi over 2, those would be my asymptotes. And again, halfway between here and the asymptote is where my quarter point, where my A is equal to 1. Okay? So tangent is going to have this form. Now, the period for tangent is pi divided by absolute value of b. So for sine and cosine, it was 2 pi. But for tangent, it repeats itself after every pi. Okay? So the vertical asymptotes, this is kind of a tricky way of saying that at pi over 2 times b plus any number of pi over b after that. So how do you graph a tangent function? So first determine the asymptotes where cosine is going to be 0. Graph 2 periods. Plot x-intercept at the center of the period. Graph the asymptotes and then plot the points halfway between the center and the asymptotes. Again, those are the quarter points, both directions. And then A units above the baseline, and that's where the curve changes directions. So we can connect the points. And we'll take a look at an example here. So using our basic f of x equals tangent of x as guide, graph y equals 2 tangent of 3x. Well, the period is going to be pi. So my A is 2. The absolute value of 2 is 2. My period here is pi divided by absolute value of 3, so pi over 3. My asymptotes, okay, are going to be at pi over 2 times b plus n times pi over absolute value of b. So it's going to be pi over 6 plus n number of pi over 3 after that. And we'll graph that in just a second so you can see what that looks like. The x-intercepts, okay, are going to be at negative pi over 3. So it's going to be where x is, this value here is equal to 1 or negative 1, and at 0, at 1, and at 2, and then at 3. So it's going to be on and on and on like that. So let's graph to see what it looks like. Okay, and again, my tick is my period, which is pi over 3 divided by 4, so pi over 12. So here I've got a tick mark at negative pi over 12, negative pi over 6, and then positively pi over 12, pi over 6, pi over 4, pi over 3, 5 pi over 12, pi over 2. So that would be 1 pi over 12, 2 pi over 12, 3 pi over 12, 4 pi over 12, 5 pi over 12, 6 pi over 12. Now, so these are my asymptotes at pi over 6, and then I'm going to add another pi over 3 to get to the next one, and I'm going to subtract pi over 3 to get to this asymptote. And then my intercepts, we determined we're at 0, pi over 3, 2 pi over 3, and so on and so forth. My quarter points here, halfway between the x-intercept and the asymptote is right here, and my A is 2. So right here is where my graph changes directions. Okay. So I'll give you a second or two to try to get those down. I would suggest, taking a screenshot of this or coming back and reviewing this to make sure you understand this. All right. So that's really all we're going to do for today. I know we went over a lot of graphing. You might want to try practicing them on your calculator to see if you can get them to look like the graphs that I had. Make sure that your window is set up correctly. Make sure your tick marks are set up correctly. But your homework for today is going to be to download the graphing packet and try to do numbers 1 through 6. And I will post the solutions to those. But again, if you want to practice on your calculator to check your work, that's always a good idea. So that's all we're going to do for today. And I'll stick around if you have any questions.